Engenhando Talks. Apresentação: Professor Fernando Lavoie.
Olá a todos, esse é o Engenhando Talks. Sejam todos muito bem-vindos. Meu nome é Fernando Lavoie, sou diretor aqui do CETEP, da Escola de Engenharia de São Carlos. Hoje a gente tem um tema bastante interessante e uma participação internacional, inclusive, aqui. Então eu vou mudar um pouquinho aqui a língua, a gente vai sair do português e vai para o inglês, para poder entrevistar a professora aqui. Well, the theme of this episode is geothermal energy. Let me introduce the guests here of this episode. The first one, Professor Fernando Lavoie from University of Leeds, United Kingdom. Thank you, Professor, for coming here.
Thank you so much for having me. It's an absolute pleasure.
Thank you. And we have the second professor, is a professor from here, from our school, from São Carlos School of Engineering, University of São Paulo, Professor Cristina Tsuha. Thank you, Professor, for coming.
Thank you, Fernando. It's also a pleasure for me to participate in this podcast.
Okay. Thank you for both to come here. Let's start. The first question. Well, the geothermal energy is a very important energy. It's a sustainable energy. And we have some research around the world about this issue. It's a new one, so it's important to talk a little bit about it. So, Professor Fleur, shallow geothermal energy is a renewable and sustainable energy solution. How does it work in general point?
Okay, so thank you very much. Geothermal energy is all about the thermal energy which is stored in the earth beneath our feet. At greater depths, this can be quite high temperature, but at shallower depths, it can be lower temperature, and we can utilize that for heating and cooling buildings, depending on where we are in the world and the time of year that we are at. So, for example, if we think back in time, humans used to live in caves, and they did this because when it was colder outside, it was warmer in the cave, and when it is warmer outside and they want to cool down, it's cooler in the cave. And that is exactly the principle we are utilizing with this technology. Now we do it in a slightly more sophisticated way, and we do it using a heat pump system, which allows us to make the temperature a bit hotter or a bit colder to the levels where we can use it to heat or cool buildings. But the principle is the same.
Professor Fleur, about to investigate the reservoir, it's quite important, and we need the work of geology, right? The geologist, right?
Like any time we work in foundations for structures, in civil engineering, we need to understand what the ground conditions are. So here at the campus, we have unsaturated ground conditions, which means that the amount of water in the soil changes from one part of the year to another. So the thermal properties of the soil also change. So that means that the ability to exchange heat with the soil changes from time to time throughout the seasons. So we have to understand that. So the combination of engineering geologists and geotechnical engineers to understand those conditions and how we can use them is important.
It's fundamental, right? And Professor Cristina, in Brazil we have the tropical weather, and we have a lot of changes in the raining season and the dry season, or the winter here in the south of Brazil. Of course, we have difference between our weather comparing to the Europe weather.
The weather, yes, clear. It's big difference, no? Here, the mean temperature in Brazil is higher, much higher compared to UK, for example, no? But in terms of heat exchange, for us, for example, in this case of unsaturated soil, during the rainy season, we can the system is more efficient because we have more water in the soil. So that's why Flair tell that it's important to understand a little bit about soils, thermal properties of soils. Geotechnical geologist is also important because in some cases we have groundwater flow, and when you have a groundwater flow, is also can prove the heat exchange. So the condition of the soil is very important, influence the efficiency of the system. In our particular case, it's variable along the year. You have unsaturated soil here in São Carlos.
Mm-hmm.
So during the rainy season, you get better heat exchange than in the dry season. But if the soil is saturated, for example, like in São Paulo, at the University of São Carlos campus, São Paulo campus, the water level is close to the ground level. So we have a saturated soil all the year, and the difference is not important. You have good results because you also have a kind of groundwater floor at the campus in São Paulo. So the groundwater movement can help to dissipate the heat in the soil. You can reject more heat in the soil because you have this contribution. So you understand the underground, so geotechnical engineers, geologists is important in this case.
And about the costs, I am thinking about to construct a foundation and plus this system. How do you think about the cost? 5%, 10%? Plus the foundation?
It'll be something of that order. It depends a little bit on the foundation construction techniques. As Christina has said, the cost of the pipes is not very much, but there is cost in the time involved in fixing the pipes to the steel reinforcement which goes into the foundation. And that is cheapest if you can do it in a factory in advance. Whether that's possible depends a little bit on the construction methodologies for a particular site and particular techniques. And then the other main cost is related to the heat pump itself.
The main cost, I think, is the heat pump.
Pump.
Because the installation depends on the type of pile, is easier and cheaper to install. We installed in pipe piles. In steel pipe pile was really easy to install, and they were also installed in CFA piles. That is a little bit more complicated to attach the pipes in the reinforced cage. But I think the cost more important is the heat pump system.
Right. And you guys have a very important collaborative project between UK and Brazil. Can you talk a little bit about this project?
Yeah, we are very privileged to have a project that is jointly funded by the research councils in the United Kingdom and FAPES in the state of Sao Paulo. It's a very unusual scheme, but it means that in the UK and here in Brazil, we both get to conduct experimental or analysis works together collaboratively for the same project. And we are working with a number of different partners in the UK, where I am at the University of Leeds, but also the University of Dundee, who will do some experiments at laboratory scale, whilst here on São Carlos, we are doing experiments at field scale. And the project is about how we can extract heat in the UK, or how we can extract cooling capacity here in the state of Sao Paulo from basement retaining walls, structures like that. So Chris is making a not quite full scale model, which is really exciting, and that's why I'm here this week.
Doing some tests. We also have this collaboration with the Polytechnic School in São Paulo. Professor Alberto is a mechanical engineer, not a geotechnical like us, to help with the part of the heat pump system, to measure the power. In the end of the project, we will do a test. We have a small house in the campus. We will compare the air conditioning efficiency using a typical air conditioning, the power that we can spend in the typical, and using this technology of shallow geothermal energy to measure the numbers, how much we can reduce in energy and in money too. So at the end of the project, we can measure, and it's Roberto that understands this part. No? This is a mechanical engineer, understand about the air conditioning system. No?
And it's a really exciting opportunity to look at a compare and contrast between the different conditions between Northern Europe and South America, essentially, because a lot of the research on these types of systems so far has happened in more temperate or certainly Northern Hemisphere climates. And if we want to really implement these solutions all over the world, we need to be thinking much more broadly. So that's definitely one of the key aims of this project.
It is very nice, and I think it's the first project in Brazil with this kind of
I think
collaborative.
In this case, you mean collaborative with other countries?
Yes, with other countries.
I don't know about other one, but I think in São Carlos we were the first energy pile constructed in Brazil was in São Carlos in 2014, 10 years ago. We started, investigated, and now we advanced more. No? We did the foundation of a building in São Paulo, and now you are doing the energy walls in this project with UK. So this is, there are other, I think now in Brazil, UNB, and in UENF, in campus, Guatacase campus in Rio de Janeiro, they are also studying something about geothermal energy. But I think it's not a collaborative. This collaborative is very good because they have more experience with this kind of technology, and we are more experienced in doing tests. So Flair developed some analytical models to help the design. In future, this is the idea. No? How to design this for this kind of condition. So this is important. It's a big project. It's 3.5 years of project. So you are in the 4th year. No?
Yeah, we are just at the beginning. But you know, the work you have already done with the piles, both here and at the Sao Paulo campus, you know, it's been really trailblazing, especially in this part of the world in these types of conditions. So it's really good to be able to extend that now into other underground structures, and to be able to, you know, positively collaborate, learn lessons between different parts of the world. What are you doing here that we can learn? What have we done that you can learn, so that we can, you know, maximize, development of these design methods and how we can apply the technology in different places.
This kind of cooperation is very good. It's very nice important for both sides. So very rich for us. We also have some students involved, other colleagues that are not here, but this is good. We can get a bigger advantage.
Yeah, we mustn't underestimate the impact of all the students involved, because these are the future engineers, right? Who will be going out there implementing projects like this in the future. So it's a real chance to influence changes in practice later.
Yeah, of course, yes. And you are this week at the field, right? What are the challenges that you are facing at the field?
Field work is always difficult. There are so many details that you must get right. The number of sensors that Chris and her team have already installed in the construction, you know, I have missed most of the hard work. I am just here for the exciting testing phase.
As to have a better understanding of the system, we installed many instrumentation. So not only temperature instrumentations, but to measure the consequences in the geotechnical structures. So to understand what happened, the pressures in the walls, etc. So have many cables inside the installation to concrete this. If it's a typical, conventional energy wall for typical use, they don't have this kind of instrumentation. It's a typical, né? But we need to do many measurements, also to calibrate some analytical models and the numerical models. We installed many sensors inside, big volume of sensors, but it would be good because you can get some have better understanding of this.
It's essential to have high quality data from real construction in order to give confidence in technology, but it's a huge amount of work to do it. So yeah, you guys have been working really hard.
So guys, we are finishing our episode right now. So I would like to thank firstly Professor Cristina. She's my partner in the Geotechnical Engineering Department here in São Carlos School of Engineering. Thank you, Professor Cristina, for coming here. I think it was a very nice conversation about future, about energy in the future, right? We are just starting this kind of matrix, but it's very important for our country. Thank you.
Thank you, Fernando. It's a pleasure for me, and also I think it's good to show to the society what kind of research you are doing, to know this technology, because I think that most people doesn't know, né?
Yeah.
So thank you for the opportunity.
Professor Fleur, thank you so much for coming. I know you are doing a very hard week because you came from UK and you are working very hard, a little bit in the office and a lot of at the field, right? But thank you for this time to talk a little bit with us about this kind of issue and to bring for us your knowledge about this.
Yeah, as I said, it's a absolute pleasure to be here in São Carlos, and it's always great to try and convey the importance of what we're doing and that understanding, because we do have to make these changes to make our energy more sustainable. So yeah, thanks for the conversation, really good.
Thank you. Bom, pessoal, então esse foi mais um episódio aí do nosso podcast Engenhando Talks. Até a próxima.